piece of code that executes independently. Every program contains one thread that is called main thread. Main thread default name is main only. Main thread default priority, normal priority. Priority number 5. Okay, minimum priority 1, normal priority 5, maximum priority 10. Priority number 1, 5, 10, like that we'll call. Now, how to set, you will see here. How many ways are there to create a new thread? 2 ways. What is the first one? By extending java.lang.thread class. Second one, by implementing java.lang.runnable interface. Any one we have to use. Okay. Yesterday, I given life cycle diagram. Okay. Life cycle diagram, thread states diagram I given. Thread states diagram, thread life cycle diagram I given. Say java.lang.object class is a super class. Java.lang.runnable is the interface. Java.lang.thread class. So one class. This class and this interface both are inherited in this class. Now, this is which type of inheritance? What happened? Multiple. It is class, it is interface. With class and interface, multiple possible. 2 classes not possible. Okay. So, it is a class. It is a interface. The class is an interface. It is a class. Here, 2 methods are there. Wait and notify. Here 1 method is there. Run. Remaining methods are here. Start method, sleep method, suspend method, resume method, and run method overridden, and destroy method. Here, it is a class, it is interface, it is a class, multi-threading. These 2 methods are concrete methods. This method is abstract method. This method is abstract method. Here, these all concrete methods. This only run method, null body method also. Write this one. Null body method. That means abstract method or concrete method? Concrete method only. Statements will not be there, but body will be there. Open brace, close brace will be there. Okay. Open brace, close brace will be there. Write this one. Is it over? So object class contains wait and notify methods. Runnable interface contains run method that is overridden in thread class. Okay. And but given as a null body method. But why they given null body method is to write a child thread task code. This method only useful. Child thread task code we have to write here only. I'll explain in the programming. Say yesterday given life cycle diagram and a thread states diagram. Thread states diagram. Those methods only here. Okay. Now here why they given run method as a null body method. If they don't give run method as a null body, this becomes abstract class. Because if we don't override, but why they given empty? This code we have to write. Child thread code we have to write in the run method only. If you want, you can write in other method, but other method you have to call from run method. But at last you have to call from run only. Okay. That note down. Run method given as a null body method in java.lang.thread class. Run method given as a null body method in java.lang.thread class to write child thread task code. Run method given as a null body method in java.lang.thread class to write child thread task code. Run method given as a null body method in java.lang.thread class to write child thread task code. Run method given as a null body method in java.lang.thread class to write child thread task code. Now I'll give the list of methods. Java P, java.lang.thread. Variables. We can call it as fields also. Fields or variables. Note down. Constructors. One minute. 1 minute. Methods. This we will see later. Note down. Minimum priority number 1. Normal priority number 5. Maximum priority number 10. Minimum priority number 1, normal priority number 5, maximum priority number 10. This long is milliseconds. Is it over? Now you observe these all methods in thread class. Here, static methods, non-static methods, final methods, native methods. If the word native appears, then you can understand this method implemented in native languages. C, C++. Say you studied abstract method. What is the concept of abstract method is declaration in superclass, definition in subclass. So declaration in one class, definition in another class. That is the concept of abstract. But native purpose is declaration in Java, definition in other languages. That type concept. So just note down. Native methods are developed in non-Java languages. Examples, C and C++. Native methods are developed in non-Java languages other than Java, C and C++. Now, how many ways are there to create a new thread? 2 ways. What is the first one? By extending java.lang.thread class. Second one, by implementing java.lang.runnable interface. You will extend thread. These are thread class methods only, no? What is the concept of final? We cannot. I'm asking final method, not variable, not class. Final you can apply to variable also, method also, class also. Final method. We cannot override. So same method name we should not write. If you write instead of this method, your method called, then suspend, it is not suspended. Life cycle method is all. So that life cycle doesn't work. That is the reason they given final. We cannot override. They're restricted. If final keyword is not there, you will write your own suspend method. Then instead of this suspend, that suspend called. Then thread is not suspended. That type of problem comes. That is the reason they given final. Okay. Now you observe. If you extend thread class, this constructor called. If you implements runnable, that runnable reference you have to pass, again thread object you have to create. If we implements runnable also, thread object required. Because new thread will born whenever thread class constructor is called. Write that point. New thread will born whenever thread class constructor is called. New thread will born whenever thread class constructor is called. New thread will born whenever thread class constructor is called. See, there are 2 ways to create a thread. Extends thread means this constructor is going to be called. Implements runnable means runnable parameter you have to pass, then constructor called, then new thread will born. So extend thread you will write. So about class demo extends thread. If we create demo object, demo constructor called, in the demo class constructor first line implicitly what will be there? Then this constructor called. Then new thread will born. Here extends thread or implements runnable compulsory. Okay. Extends thread you will write. Class demo extends thread. Then you will create demo object. Demo constructor called. In that constructor first line super will be there. Then this constructor called. Then new thread will born. Implements runnable if you write. Demo object will create. Demo object you can pass no here. Runnable is super interface. Demo is subclass. Subclass object you can pass no upcasting. Then again new thread will born. So if you write extend thread, this is. If implements runnable, this is. This method, wherever you call, that is current thread. Wherever you call. In a child thread, if you call child thread, main thread, if you call main thread. Sleep method, life cycle method, milliseconds it will sleep. Start method, ready. Run method, running. Suspend, resume. These all you studied. Life cycle methods. Set priority. One priority you can pass. Year. Minimum priority if you pass, it will be 1. Normal priority if you pass, 5. Maximum priority, 10. Are these instance variables or class variables? You have to pass here class name dot priority. You can find out, get the priority. You can change the name. You can get the name. Name of the thread. You can retrieve. You can modify. This is all present in thread class. Next, Java P java.lang.object class. Methods. Wait, notify. So wait method, notify method. Here they given final also, native also, you observe. So these two methods are present in object class. Notify method, wait method. Now one more is there, interface, runnable interface. Is it over? Java P java.lang.runnable. Here one method. Write this one. Run method. No need to override. Already overridden in thread class. But it is empty method. Again, you have to override. But if you implement runnable, compulsory you have to override. If you extend thread, also you have to override because that is empty. Okay. Now, is it over? Now we'll see the programs, multi-threading programs. Now, class name, open brace, close brace. Main method, open brace, close brace. It is common for every program. Now, in this program, any thread is there? Yes or no? Yes. Every program contains at least one thread. That is main thread. There is a main thread. So operating system will provide one service, one process to this program. That is only main. From this, you will create. That is only child. Through your coding, you are writing. That is child. Operating system is giving no. That is main thread. Okay. Now it is main thread. This thread name I want to retrieve. This thread priority I want to retrieve. Every program contains at least one thread. That is main thread. Main thread default name is main. Main thread default priority 5. Normal priority 5. For getting name, getting priority, what are the methods required? See, get name, get priority. Get name method is there, get priority method is there. These two methods required. Those two methods, you see the notes, instance methods or class methods? Instance methods. Okay. I want to call those methods. Now, how many ways to access? What are those? Which class object required? Thread class. Suppose if we create thread class object, new thread will born. I don't want new thread. I want to find out this thread information. That is possible with current thread. Okay. With current thread method is, see the current thread method. Is it accessible? Yes. Is it instance method or class method? Class method. What is the return type? Return type also thread. Return type also thread. Okay. Now that method I want to call. What we have to write? Thread T equal to thread dot current thread. Current thread method, instance method or class method? Class method. That is the reason we are calling with class name. Class name. Thread dot current thread. Okay. What is the return type of this method? That's what thread T. See, for calling current thread class name required. Again, it is returning thread class object only. That is referred by thread class reference. So if we call this method, it returns thread class object. That object referred by thread class reference. This type of methods are called factory methods. It will produce the object. That is, further we will study. Separate topics are there. After advanced Java. Design patterns. Design patterns also are there. No? We will study. Factory methods, singleton class objects. So many concepts. Java is very vast. Subject is very vast. You have seen core Java only how many days it has taken, you observe. But advanced Java, Spring Framework, Spring Boot, microservices. Subject is very vast. Years also you can learn. It is not going to end. So, thread dot current thread. Current thread is a static method. Current thread is a static method. I'm calling with thread because static method. It returns thread. Now, here system dot out dot println T if I write in a thread class, toString method overridden. ToString method overridden. With that, thread name printed, thread group printed, thread priority printed. This is I'll cover later. Present, I want to call get name, get priority methods. Now, get name. What is the return type? String. What we have tried? Give me answer. String sc equal to t dot get name. Next, system dot out dot println. Yes. These two lines can I write as a one line? What we have to write? T dot get name. Next, priority. System dot out dot println get priority. Okay. Now demo class loaded, main method called, current thread method called. This thread only. Current thread object referred by thread reference with this name of the thread printed, with this priority of the thread printed. File, save. Java C demo.java. Java demo. See, name of the thread, main. Priority of the thread, 5. I want to change the name of the thread. Which method we have to call? Set name. What we have to write? Return type? Void. What we have to write? T dot set name. Any one name you can pass. Suppose it is sample thread. Name sample. Next. T dot set priority. Suppose 10. Instead of 10, I want to pass variable name. What is a variable name? Max priority. Is it instance variable or class variable or local variable? Then how to pass? Thread dot max priority. Okay. Now, again I want to print system dot out dot println t dot get name. System dot out dot println t dot get priority. Okay. File, save. Thread class in which package? Java dot lang package. Okay. No need to import default package. So current thread comes, that is referred by T. Current thread name printed, main. Current thread priority printed, 5. I change it to sample. I change it to 10. Again I printed name sample printed. Here 10 printed. File, save. See, name of the thread, main. Priority of the thread, 5. I change it to sample. I change it to 10. Again, sample 10 printed. Now, my question is it single thread program or multi-threaded program? Single thread or multi-threading? Single thread only. Okay. If you write extends thread or implements runnable, then only multi-threading. Write this one. Program to get current thread information. 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 Is it over? Here, current thread method called. Already told you, current thread means not only this thread. Suppose this method, if we call in other place also, that thread current thread. Suppose later we'll create 2-3 threads. This method, wherever you call, that is current thread. Okay. Suppose this is main thread. One more child thread I'll create. This method, if I call there, that is child thread. Here current thread means main thread. Wherever you call, there only. See, this is a keyword. What is this? Current object. Is it? Can you specify it is employee object, demo object? Wherever you write this keyword, that object. Like that. Current thread method, wherever you call that method, that thread. It is always not main thread. Current thread means it is not always not main method, main thread. That line, wherever you write, that thread. So, current thread method called. This thread, reference referred by T. With that, get name of the thread printed, main. Get priority, 5. Default name, main. Default priority, 5. It is name changed, priority changed. Again name sample printed. Again priority 10 printed. Okay. Now, this is programmed to get current thread information. Now, here one loop I'll write. For loop integer I equal to 1, I less than or equal to 100, I plus plus. System.out.println I. In this program, any thread is there? Yes. That is only main thread. That thread is printing 1 to 100. This 1 to 100, it is printing in a fraction of seconds. Not even 1 second. See, observe. Below 1 second only. Below 1 second only it is printed. Below 1 second only it is printed. Okay. Fraction of seconds only 1 to 100 printed. Now, every second, one number I want to print. Which method we have to call? Which method? Sleep. Sleep method we have to call. Sleep method, is it instance method or class method? See. Sleep method is class method. How to call? Thread.sleep. So, thread.sleep. Suppose 1000. 1000 milliseconds equal to 1 second. So 1 second it will sleep. Say I value 1. 1 less than or equal to 100, true. 1 printed. 1 second it will sleep. It will become 2. 2 less than or equal to 100, true. 2 printed. Again 1 second sleep. Every second one number printed. Okay. Will it throw exception? Which exception? Already in the exception handling hierarchy, this exception was there, no? It is checked or unchecked. Even if you don't know how to see, with the Java P command, you can see Java P Java dot lang dot interrupted exception. Interrupted exception extends. It is checked or unchecked. Checked exception. Even if you don't know, like this you can see. Otherwise, one more way, compile the program. If you get a must be caught, checked. Now, try catch exception. Can I write? Yes. System.err.println E. Otherwise, interpret exception you can write. Okay. Now you observe compilation execution. Every second, one number printing you observe. Okay. Every second, one number printing. So one printed, 1 second sleep. Again, two printed, 1 second sleep. Again, three printed, like this. Every second, one number. Is it single thread program or multi-threaded program? Still, it is single thread only. Okay. Only sleep method added. That's it. Okay. Ready, son? Program to demonstrate sleep method. Is it over? Now this thread is printing 1 to 10, 1 to 100 every second, one number. Now, how to create multi-thread application, I'll show you. These are single thread programs only till. No done. Steps to develop multi-threaded application by extending java.lang.thread class. Steps to develop multi-threaded application by extending java.lang.thread class. Steps to develop multi-threaded application by extending java.lang.thread class. First step, create a class that extends java.lang.thread class. Create a class that extends java.lang.thread class. Create a class that extends java.lang.thread class. Second step, override run method. First step, create a class that extends java.lang.thread class. Second step, override run method. Actually, run method not compulsory to override. It is null body method only. But for this program, you must override. Okay. Next, write child thread task code in a run method. Write child thread task code in a run method. Create a class that extends java.lang.thread class, override run method, write child thread task code in a run method. Next, write main method. Write main method. Next, create an object of current class. Create an object of current class. Call start method. Note, start method implicitly calls run method. Call start method. Start method implicitly calls run method. Write main thread task code. In a main method. So this is a way to write multi-threaded application. Any application, writing program style is same. Task may be different. Task may be different, but writing program is same. These 7 steps you need to follow. Now, is it over? See, these 7 steps you need to follow. First step, you have to extend thread class. Second step, run method you have to override. Third step, write child thread task code inside the run method. Run method is empty they given. Now, next main method you have to write. Next, create object of current class called start method. Start method implicitly calls run method. So calling run method code already written inside the start method. You call start calls run. That type already written. Write main thread task code in main method. Now, according to steps, we will see. First, what is the first step? Create a class that extends java.lang.thread class. What we have tried, give me answer. Class demo extends thread. Okay. What is second step? What we have tried? Override run method only. What we have tried? Public void run. Already overriding rules you study, no? Access modifier. What is there? Here public only required. Return type void. Run method parameter same. Third step. Write child thread task code. Here something child thread task code we have tried. Next step. Write main method. What we have tried? String args. Next. Write main method over. Next. Object of current class. Which class? What we have tried? New demo. Next. Start method in which class? Start method in which class? Thread class. Can I call d dot start? Now, d is a reference of which class? So, demo class reference I'm using. Start method in thread class. Super class method I'm calling with subclass. Valid no? What is next step? Run main thread task code in the main method. We'll write like this. What will happen? Just observe. This is child thread task code. This is main thread task code. Now, what will be happen? Just observe. First main method called. Okay. First main method called. This is one thread. Okay. First main method called. After this, open brace executed. After this, object created for demo class. Here, any demo class constructor is there? No. Will it implicitly provide Java compiler? Yes. That constructor first line, what will be there? Super. Then what super keyword will do? Super class constructor called. Then new thread will born. It is new thread. It is main thread. So this is one child will born. It is main. Now actually here one only. It is divided like a two parts. Now this is child thread. This is main thread. So this is called child thread. This is called main thread. Now child thread in born state, just born. Start method called. Okay. Start method called. Whenever start method is called, thread will be ready. Child thread now ready. Start method implicitly calls which method? Run method. Then the child thread calls run method. Then open brace. Then task code. This part executed. At the same time, this main thread, this part executed. Whatever you written code, that output comes to output window. Whatever you written code here, that is comes to output window. Whichever comes first, that will print first. Can you predict which is going to come? No, because multi-threading. This is multi-threading. Okay, write this one. You can understand easily. If you write the diagrams also, easily you can understand, even if you open notebook after 1 month also. Today you will understand without that also. But maybe tomorrow only some people they may not understand. It will be happen. Because all people grasping power not same. You observe while asking question, how many people are giving, how many people are not giving, observe. All are not giving answer, no? This type of diagrams will not be there in book. Understanding purpose myself I given like that. Okay. Multi-threading code only will be there. But like that, how it is executed, I written that on. That will not be there in book. Understood what I said? Just you observe. Once again, I'll explain. Because same procedure. This is called way. Later, any program you can write. Task may be different. This is called way of programming. See, first main method called. Okay, first main method called open brace executed. Here object created. Whenever object is created, constructor is called. We don't have constructor. Constructor implicitly provided by Java compiler. In that constructor first line super will be there. It calls super class constructor. Then new thread will born. Okay, new thread will born. Whenever thread class constructor is called, then new thread will born. So thread born state. This is main thread. Here start method called. Then child started. Nothing but ready. Start method implicitly calls run method. So control comes here. Then thread is running. Here open brace, this task code executed. At the same time, main thread will come here. Whatever you written here, both will run simultaneously. This output passes to output window. This output passes to output window. Whichever comes first, that will print first. That is the concept. Clear? These programs we'll see tomorrow.